Okay, an unbiased cubical dice has the numbers from 1 to 6 denoted by spots on his faces as shown below. The dice is rolled twice. What's the probability that a 3 is thrown both times? So it's thrown twice, okay? So we've got to be careful here when we're working out the probability, right? Unbiased, just think about that for a minute. Unbiased means it's a fair dice. Okay, this dice has been designed properly. It's not sort of weighted on one end, which you can create a dice where maybe it's more weight on one end and it will land on a particular number more often. That's not the case here. It's unbiased. It's a fair dice, all right? Now think about the probability, first of all, and I'd write that like this. Probability of getting a 3, right? That's what I'd write here. Probability of getting a 3 on the dice. Well, on the dice, there are 6 possible outcomes, aren't there? Okay, so I'd say it's out of 6, right? And if you think about it, 3 comes up just once, doesn't it? Okay, you've got all the outcomes on the dice. You've got 6 different outcomes, and 3 only comes up once. So you've got 1 chance in 6 of getting a 3, okay? But what chance have you got of getting a 3 twice? If the dice is rolled twice, you get a 3 on the first throw, a 3 on the second throw. If you think about it, there should be a less chance, isn't it? Less chance of doing that. It's quite hard to do that, isn't it? You know, if you were playing a board game and you have to get a double 6 or something, it's really hard to do that. And the same with double 3, it'd be really hard. So probability of getting a 3 is 1 over 6 on 1 throw. But what about 2 throws? Well, this introduces us to our AND rule, okay? Now, with our AND rule in probability, it means we multiply, okay? Because they're like independent events, okay? Throwing the dice the first time will not affect what goes on the second time. And the way I write this is as follows. I just write it like that. Probability of getting a 3 on the first throw and a 3 on the second throw. So probability of getting a 3 on the first throw is 1 in 6. And then, so we multiply, probability of getting a 3 on the second throw is still 1 in 6. And when you work that out, times the tops, when you multiply fractions, 1 times 1 is 1, times the bottoms, 6 times 6 is 36. So 1 chance in 36. You could see then it's a much smaller chance of doing that. It only happens 1 in 36 occasions. So do the same then. This one, Megan has a fair side 6-sided dice. She throws the dice twice. Calculate the probability that she throws a 4 both times. Now, does it really matter what number it is? Probability of getting a 4 is still 1 in 6, isn't it? Okay, it doesn't make any difference. So probability of getting a 4 and a 4, it'll be 1 over 6 times 1 over 6, which is 1 in 36. Now, I can also actually prove this in like a sample space, okay? It takes a little bit of time to set up, but I can show you that if we have, for instance, the throw 1, right? First throw on the dice, and then throw 2. Okay, now on throw 1, you've got 6 possible outcomes. On throw 2, also you've got 6 possible outcomes. Now, if I was to then list the outcomes, so for instance here, I'd get 1 on the first throw, 1 on the second throw. Okay, you get 1, 1, and then here, if I had 1 on the first throw and 2 on the second throw, I'd have 1, 2. That would be my outcome. Or 1 on the first throw, 3 on the second throw, and so on, right? If I kept doing that, okay, you know, if on the first throw I had 2, and then 1 on the second throw, or 2 and 2, 2 and 3, listing all the possible combination of outcomes from the first throw to the second throw. If I did that, okay, then you will see that I would have 36 outcomes. Okay, I could keep going and bore you to death on this. Okay, I hope you can see I've got 6 in each row, and that would mean I've got 36 outcomes then, because I've got 6 rows. Okay, so I've got 36 possible outcomes. So that's why it's out of 36. Now let's see where 3 occurs twice. Well, it only occurs twice there, doesn't it? It only occurs twice on one occasion, so 1 out of 36. So that's one way of doing it. Obviously, it's a lot quicker using the AND rule. You just multiply the probabilities. Okay, just to finish off, it says Sanesh throws 2 fair dice. He scores a double 1. calculate the probability of not scoring a double 1. Now we've already established to score double 1 would be that, wouldn't it? 1 over 36, okay? We've established that from before. It's going to be the same for a double 1. Not scoring, well that would mean, so if I'd say not scoring 1, 1, that would mean, of course, you've got 35 chances out of the 36. You just see what's left from here. If you did this 36 times, you should only expect double 1 to come up once. That means the other 35 times it will be not scoring a 1.